Hi everybody, it's Mrs. T. Hope you've all been doing well. I hope that you know by this point that I'm taking questions by remind or email and sending out quick video snippets to help to review them. A question was asked about Gibbs free energy and delta G and how it relates to H and S. First of all, don't forget that delta G stands for Gibbs free energy. And negative Gibbs free energy will mean that you have a favorable chemical process or physical process. And don't forget that activation energy still plays a factor, but negative delta G means that the process is thermodynamically favorable. One of the formulas that we can use to find delta G is delta G equals delta H minus T delta S. Please remember or keep in mind that delta H and delta S are generally given in different units. Delta H is usually given in kilojoules. Delta S is usually given in joules per Kelvin. So you will usually need to convert the delta S into kilojoules in order to use them both in the same formula here. Again, we said that negative delta G would mean that something is thermodynamically favorable. The other factor that comes into play is activation energy. So don't forget that if something has a really negative delta G and it doesn't happen on its own or doesn't happen a lot, that would mean that you would be left to conclude that the activation energy must be very high. We know that all temperatures will have a favorable situation in terms of delta G. If we have a negative delta H, which again is exothermic, and a positive delta S, which is increasing the entropy. Remember, negative delta H, again, exothermic, downhill potential energy diagram, release of energy. Positive delta S, increasing the entropy, which would happen by increasing the molecules, increasing the number of gas molecules, or making a mixture. All temperatures would be have a favorable situation for a negative delta H, positive delta S. If the signs of the delta H and the delta S are the same as each other, negative H, negative S is favorable at low temperatures. That's when mathematically the delta G comes out to be negative. Positive H, positive delta S, that would be favorable at high temperatures. And again, that is when mathematically the delta G comes out to a negative value. If you wanted to know what temperatures a reaction would be favorable, you would have to set delta G equal to 0 and put X in as your temperature. For the negative situation, it's all temperatures lower than the temperature you solve for. And for positive, it's favorable at all temperatures higher than the temperature you solve for when temperature is X and delta G is 0. And then finally, we know that the opposite of the situation that's always favorable would never be favorable. Positive delta H, which is endothermic, and negative delta S, which is decreasing the entropy. Plugging those into the delta G equals delta H minus T delta S formula will always give us a positive G, which means that those situations taken together will never make for a favorable reaction or thermodynamically favorable reaction, because the delta G will always come out to positive mathematically. So hopefully this helped with review of Gibbs free energy. Hope everybody's hanging in there during this COVID-19 coronavirus terrible situation that's going on here. I hope that you are all safe and healthy, and please feel free to contact me with more questions or poke around at Mrs. T Chem Talk on YouTube, on the YouTube channel, to see if there's something else that can help you out. All right, happy studying.